Hello students, this is Vijay. In the last lecture, we have studied different applications of adsorption. In that, we have studied the three applications, that is the application of adsorbents in the purification of water. So, in the purification of water, we use the different adsorbent. Therefore, the different adsorbent adsorb the material that are different ions present in the water, and the water gets demineralized because the different minerals from the water get eliminated. Therefore, the water gets purified, and thus the use of adsorbent in the purification of water. Next, we have studied the application, that is the production of high vacuum. So, in many organic reactions, the required condition, that is a high vacuum. Therefore, for the production of high vacuum, the adsorbent, the role of adsorbent is the to adsorb the different gases from the reaction mixture. So, therefore, there is production of high vacuum. And the last application, that was the chromatography. So, by the chromatography, this was the technique. This is the technique to separate the constituents of a mixture based on their selectively adsorption from the solution. Therefore, we have studied, that is a chromatography. In that, we have studied the column chromatography. So, this is the last lecture for your surface chemistry chapter, and today we will end this chapter. So, in this lecture, we will study remaining three applications, that is adsorption indicators, and indetermination of surface area, and some other applications of adsorption. So, what are the adsorption indicators? So, the phenomena of adsorption is used to detect the end point of some precipitation titration, because we know that what is the indicator. You may have performed the experiments. So, in the experiments of titration, what we use? The different indicators. So, what is the role of this indicator? So, this indicator changes the color. So, in generally, we use the phenolphthalein indicator for the acid-base titration. So, the use of adsorbent as a indicator, that is the application, that is a adsorption indicator, and the phenomenon of adsorption is used to detect the end point of some precipitation titration. Because what is the role of indicator? To detect the end point of titration. Because when we use the phenolphthalein as an indicator, we know that what we got the end point, that is a faint pink color. So, what is the role of indicator? Role of indicator is the to detect the end point of some titration. And here we will study the precipitation titration. So, the precipitation titration of solution of sodium chloride against the silver nitrate solution. So, in this we will study the precipitation titration of solution of sodium chloride NaCl against the AgNO3. So, if we combine these two, NaCl and silver nitrate, that is AgNO3. So, NaCl and AgNO3, what is formed? So, solution in presence of some indicators like bromocresol blue. So, here the indicator is used called as a bromocresol blue, is an example of this type of titration. And the bromocresol blue, we know that what is the color? Bromocresol blue, it's blue in color, and it has a colored anion in it. So, it has the presence of colored anion. And when the silver nitrate solution is added gradually to the solution of sodium chloride. So, what form? So, silver, there is formation of silver chloride. So, from the silver nitrate, the silver, and from the sodium chloride, the chloride gets combined, that is a silver chloride, that is AgCl precipitate, white colored precipitate of AgCl is formed. And after the complete precipitation of silver chloride, that is white colored precipitate, any further addition of silver nitrate. So, in this experiment, we fill the burette with the silver nitrate, and in the conical flask or beaker, we take the sodium chloride. So, when the complete precipitation, when we add the silver chloride, when we add sodium chloride into the silver nitrate, so there is precipitation of sodium chloride. So, what happens? So, after complete precipitation of sodium chloride, silver chloride, any further addition of silver nitrate will increase the concentration of silver ions in the solution. Means As the end point is reached, after more addition, the concentration of silver nitrate will increase the concentration of silver ions in the solution, and the silver chloride now adsorbs the colored anion of the indicator from the solution, because as the end point is reached, so all the precipitate of silver chloride is formed. Therefore, the silver chloride adsorbs now the colored anion of the indicator from the solution, and the changing color of the precipitate is the end point of titration, because here we got a white color precipitate. It becomes color become changes, and that color change is the end point of this titration. And the silver chloride in the solution in presence of excess of chloride ions, means that once the precipitate of AgCl is formed in the solution in presence of excess chloride ions, if excess chloride ions are present as the stage before the equivalence point, means if before the equivalence point of titration represented by AgCl, means silver chloride precipitate in presence of some chloride ions which is a negatively charged, and this calcium not attach the anion of the indicator to themselves, but the concentration of silver ions increases as the particles of precipitate becomes positively charged, and Ag plus this immediately adsorb the colored anion of the indicator. The dyestuffs such as eosine, fluorescein, etc. are also used as indicators in such titrations. Alizarin radius indicator is also used in the titration of lead silver nitrate versus the potassium ferricyanide. So these are the different titrations in which first we have studied the sodium chloride with silver nitrate, that there is the formation of silver chloride precipitate. Dyestuffs such as eosine, fluorescein are also used as indicators. Alizarin red, it is a red color. Dark red color is also used as indicator in the titration of silver nitrate versus potassium ferricyanide. And diphenyl carbazide indicator, this is also one of the indicator used in the titration of Hg2 plus versus Cl minus or Br minus. These are the additional examples of adsorption indicators. So this is the application for the adsorption indicators. So next application is in the determination of surface area. So what is the role of adsorbents in the determination of surface area? So adsorption of gases on the solid. We know that the gases are gets adsorbed on the solid adsorbent, that is charcoal. We have studied that example. So absorption of gases on the solid surface is powerful tool used for the determination of surface area of the solids in their finely divided states. And in addition, the solution solid system may be used in the determination of surface area. For example, if the finely divided powdered lead sulfate is shaken with the solution containing radioactive substance like a thorium B. Means, if you consider the example, that is finely divided powdered lead sulfate, that is a PbSO4, is shaken with or mixed with the radioactive substance like a thorium B. So what happens? An exchange reaction occurs, and at equilibrium, the ratio of two atoms on the surface of PbSO4, that is a lead sulfate powder, will be equal to that of in the solution. Means the ratio of two atoms, that is atoms of lead sulfate on the two atoms on the surface of lead sulfate powder will be equal to that in the solution. And as the equilibrium is attained or reached, rapidly it is probable that exchange reaction involves only the surface atom, because the equilibrium is fastly attained. Therefore, the exchange reaction involves only the surface atoms. And the quantity of lead in the solution from the lead sulfate, the quantity of lead in the solution can be determined analytically, and that of thorium B by the radioactive method, because thorium B is a radioactive. Therefore, by radioactive method we can determine the quantity of thorium B, and it is then possible to calculate the number of atoms of lead and hence the molecules of lead sulfate on the surface of weight of given lead sulfate powder. And from the knowledge of the size of lead sulfate molecules, the area of exposed surface can be calculated. So this is the application for the determination of surface area. So this is also one of the most important application. So next and the last application, that are some other applications for the adsorption. First is the ferric hydroxide is a good adsorbent for the arsenic ion. Means the different adsorbents are the good adsorbent for different reactions. So ferric hydroxide is a good adsorbent for arsenic ion. So arsenic salts are very poisonous. We know that arsenic is very poisonous. The ferric hydroxide is used as an antidote in case of poisoning by arsenic. So if in case the poisoning of arsenic takes place, so what is the role of ferric hydroxide? It is a good adsorbent for the arsenic ion. Therefore, by the treatment of arsenic poisoning, we use the ferric hydroxide as an antidote. So in the preparation of gas electrodes in the electrochemical cells, the gases are adsorbed on platinides platinum. See, this is also one application. Coconut charcoal adsorbent is used in the efficient separation of inert gases from the mixture. So this is also one adsorbent, coconut charcoal. This is used for the efficient separation of inert gases. Some inert gases, if present in a reaction mixture, they can be separated. Dirt and green, it can also be removed by adsorbing these materials on soap leather. We know that what is the function of soap leather? So it removes the dirt and green by the adsorption. In the decolorization of sugar syrup, so decolorization of sugar syrup, the charcoal acts as a adsorbent. We know that charcoal is a very good adsorbent. So in the decolorization of sugar syrup, charcoal is a adsorbent. Fuller's earth is used to remove the colors of vegetables or mineral oils. So, to remove the colors of different vegetables and mineral oil, the Fuller's earth is an adsorbent. So, these different adsorbent, that is the coconut charcoal, Fuller's earth. So, these all are we have studied in the different adsorbents. And it is used, Fuller's earth is used for the removal of vegetable and colors of vegetable and mineral oils. And last application is the granular charcoal. So granular or powder form charcoal is employed in the gas masks. So gas masks use the granular charcoal, and what is the role of this granular charcoal? It adsorbs the poisonous gases like chlorine, marsh gas, mustard gas from the atmosphere. So these different gas masks, it contains the granular charcoal, therefore it adsorbs some poisonous gases like chlorine, marsh gas, mustard gas from the atmosphere. So these are the all applications of the adsorption. So thank you. So what different applications we have studied? The first one and most application of the adsorption was the catalysis, role of adsorbent in the process of catalysis. Next application that we have studied in the purification of water. Next, that is a production of high vacuum chromatography, and now we have studied the three applications, that is a role of adsorption as a adsorbent as a absorption indicators, and in the determination of surface area, and some other applications of adsorption. So in this way we have completed our second chapter and also the our syllabus for the physical chemistry course. So now prepare for your upcoming exam on these two chapters and solve some problems on the first chapter and second chapter. We will take one lecture for problems also. Thank you.